Hello, this is Nick of Time. Welcome to this our 19th talk on the physics of time. Today we're going to focus a little bit more on critical thinking, give it a little more color and depth, and also look at the bonds that our belief systems have on us and how they can constrain us sometimes. But first, we'll review the summary of last time where we made our first step towards building a new foundation for putting time back into physics. We use proper time as the key construct for that, and in the second bullet says we've replaced the relativity or relative simultaneity with absolute simultaneity and universal time or standard time to restore the construct of past, present, and future, which is a fundamental property of time. Okay, and we're going to look at how other people have looked at that topic in that second bullet. First, we're going to talk about Professor Lee Smolin, who's a very well-known, well-respected mainstream physics professor, currently working at the University of Waterloo and the University of Toronto, and the founder of the Perimeter Institute. In the past, he's been a visiting scholar at the very prestigious Institute for Advanced Study and at Imperial College London, visiting professor there. In addition, he's a critical thinker. He's written 2 books using that critical thinking mode and critiquing currently accepted physics. His first one was very popular, The Trouble with Physics, where he looked at problems with string theory. His second book is what we'll talk about, Time Reborn. We'll look at his views of time. First of all, Professor Lee Smolin is an ardent relativist. Here are some quotes. I think it's often helpful to get direct quotes from people. In his books, he says, Einstein's 2 theorems of relativity are theorems of time, or better, timelessness. It replaces a wrong intuition by a deeper intuition that experiment tells us is closer to the truth. So that clearly makes the point that he's an ardent relativist, and I think it goes without saying that we would disagree with that last phrase there, and we're trying to replace the wrong intuition of, well, it's really the wrong math modeling view of special relativity with a deeper intuition of physical reality. Okay, secondly, he says, later I discovered that there's very little in physics to match the conceptual clarity and elegance of Einstein's theorems. Well, I'm sure that Professor Smolin has good intellectual views for coming to that conclusion, but at the same time, I think that statement, the way he articulates it, shows that there's a deep, emotional, strong bond to relativity theory. Okay, we're going to repeat a slide we had earlier. These are, again, his quotes, where he talks about how general relativity removes the essence of time. So he's admitting this problem or limitation. So Lee Smolin, he's quoting, talking about general relativity, but most of what he says also agrees with, is also relevant to special relativity. General relativity just goes one step further in removing time from physics. Okay, relativity treats time as if it were another dimension of space. Minkowski diagrams in special relativity, for example, are an example of that. Relativity gives a description of the whole universe as a mathematical object which is timeless. In relativity, time has been spatialized or geometricized. General relativity removes the construct of past, present, future, which most would consider as an essential physical property of time. So, how does he cope with this dilemma? On the one hand, he's an ardent relativist. On the other hand, he sees this problem or limitation in relativity. So he says a preferred notion of time, which he sees needed in some areas of physics like cosmology, implies a preferred state of rest, reminiscent of the Aristotelian notion of rest or the ether of 19th century physics, both of which Einstein punctured with special relativity. So we see both ardent relativists and an ardent rejection of the ether model thinking of 19th century physics. And by the way, I'm not really a proponent of necessarily bringing back the notion of the ether, just having a single preferred frame where motion with respect to that single preferred frame causes certain physical effects, such as slowing of clock rates. Smolin goes on to say, there's not only a contradiction here, but also cause for depression. The elimination of the ether was a great triumph of focused reasoning over lazy habits of thought. So we see a double obstacle for getting rid of relativists and going back to preferred frame thinking. So, what is Smolin's resolution? Despite the timelessness of relativity, Smolin keeps general relativity. But when a fuller conceptualization of time is needed, such as in cosmology, Smolin uses an alternative theory, namely shape dynamics. Shape dynamics is compatible with general relativity, but it replaces relative simultaneity with relative size of physical objects. You can't compare the size, in shape dynamics, you can't compare the size of objects that are separated by a large distance. So Smolin says, this means giving up the relativity of simultaneity and embracing its opposite, that there is a preferred notion of global time and a preferred frame. So let's just take a look at Smolin's evolution of thinking. On the one hand, he's an ardent believer in accepted theory, namely, or specifically, special relativity and general relativity. However, he has a critical thinking side that shows him there's a problem and a limitation with those two theories. So that's, in my opinion, that's great. I give him an A+, not in the sense that I'm a teacher to Smolin, the student, but that's just a nice shorthand for saying, hey, I like that. Furthermore, he searches out a solution, and again, this is great. So he's, in my subjective view, he has taken the first steps towards doing a complete job of critical thinking, but at this point in time can't break sort of the emotional or psychological bonds with his beloved belief system of relativity. Again, my personal opinion. All right. We'll look at another professor of physics, Professor Franco Soleri. He's an Italian physics professor and winner of Italy's most prestigious prize in physics. Has a whole bunch of prestigious associations in physics. And down to the last phrase in the first bullet, he's not only well respected in Italy, but internationally, and has received a medal in physics from Poland. He's the author of a book called Weak Relativity. Interesting title to that book. Let's remember that title, Weak Relativity. We'll take a look at weak relativity. Again, we're going to use the professor's very own quotes. Soleri says, several phenomena on accelerating systems imply absolute simultaneity. And he has 6 chapters on that point, giving 6 independent proofs of the physical reality of a single absolute simultaneity. Further, he says, such a modification, namely going from relative simultaneity to absolute simultaneity, would imply a reformulation, that's an important word to remember, a reformulation of the relativistic idea itself. It doesn't say discarding it, but a reformulation. So he says, after our results of thinking through and analyzing this shift to absolute simultaneity, relativism, although weakened, is not dead, but survives in milder forms. So Soleri is not really an ardent relativist. He's not bonded to it, but it's still, if you've been brought up in it, it can be hard to totally get rid of it. So rather than totally discarding it, he makes a fundamental change when he goes from relative simultaneity to absolute simultaneity. But notice his words about a reformulation and that relativism is not dead but survives in milder form. So another take on getting rid of or acknowledging a problem about relative simultaneity. Professor Soleri sent me a pre-publication version of his book, Weak Relativity, for me to review and give him feedback. I did so. I told him that, well, obviously after you've developed a physical theory, it's perfectly fine to have transformations between frames, but my comment was that I really didn't like the frame transformations, which are really just a mathematical tool to be driving the theory. For example, if you use something like Einsteinian synchronization of clocks, then you're building your theory on a tenet where that tenet is not consistent with physical reality. So at best, you're doing something like relativistic math modeling. But certainly it was a great effort and would be a great step forward. people who say, I agree with nick of time. Well, that would be rather self-centered. The point being that we tend to have agreement among ourselves, and each person we talk about really independently went through very similar steps, and general agreement, but sometimes some relatively minor differences. We've spoken about Ron Hatch, known worldwide for his expertise in navigation systems like GPS. He has 30 plus patents for the GPS system. Obviously he knows the GPS design and algorithm and data in great detail. And he has reviewed my comments about how GPS was not built on special relativity model, and how the data sharply disagrees with special relativity, and more along agreement with the Lorentz relativity model for time and clock retardation as a function of motion with respect to a single preferred frame. Tom Van Flandern, he was a technical consultant on GPS. And his view was that GPS does not use the special relativity model for velocity effects on time, but instead uses the Lorentz relativity model for velocity, absolute velocity, causing clocks to slow down. The late, great Tom Phipps, he wrote a book, Old Physics for New, and here's a quote from him. The satellite clock in GPS must see and measure the Earth clock not as slowed, but as continuing to run fast. In summary, the special relativity theory tale of seeing or measuring time-keeping symmetry is a myth. Manifestly, there is a real, measurable asymmetry of physical clock rates. Very important endorsement. Tom was kind enough to, as a gift, send me his book, Old Physics for New. Basic agreement. I looked at his chapter on the twin paradox and noted that he'd made a mistake there. He tried to get away from relativity and explain the physical clock rate slowing in terms of work. The problem is that it takes a positive amount of work to accelerate a clock and a positive amount of work to decelerate a clock. And so he ended up with the same problem as special relativity, where it takes positive acceleration to change velocity up and positive acceleration to change velocity down, whereas you have to have it in terms of absolutes, where you have, if you're increasing, that's a positive. If you're decreasing, it's a negative. So he agreed that that was a mistake. And so we've looked at a number of different people who focused on this problem of and limitation of relative simultaneity, limiting what you can do in physics, and you've gotten, say, general agreement on that, but different ways of treating it in different paths that people have taken. So, on the one hand, if you're doing critical thinking, that doesn't guarantee that you're going to come up with the right answer. But you need a lot of people doing critical thinking to make progress. If no one's doing critical thinking, you're not going to make any progress. So that was looking at different people and looking at critical thinking and at various degrees of people being bound to currently accepted theory and how that affects their thinking. Next time, we'll give more detail on our foundation for building a new theory to replace special relativity. Thank you very much for coming and joining me today, and hope that you will join us next time.